Hey guys, Dr. Brown here, and tonight we're looking at a trig sub problem. I don't know about you, but I like to revisit things I've worked on in the past. Sometimes I'm like, oh, how did I do that? So I like to keep practicing in different areas. For example, today I picked up an old statistics book and I'm thinking, oh man, I used to be able to do some more of this than I am today, so I need to work on that. As a matter of fact, as an engineer, every engineer should know just basic probabilities. They should know mean, standard deviations, modes, medians. They should know conditional probabilities. They also should know hypothesis testing. And hypothesis testing would be, I have material A and material B. Sourcing wants me to go from one material to another. So then I'm looking for the failure modes that material may have: ductile fracture, corrosion, fatigue, fretting, spalling, wear, all of those things. How do I turn that on and off in a lab and get then the strength of that material, but then do a hypothesis test and compare one to the other? So maybe that's a great video in the future, so let's hold that thought. But today, trig sub, okay, our favorite subject. When you look, and I know the, what's the guy's name? Black pen, red pen. Look at his videos. The guy is phenomenal. But he has some videos that are like the 100 integration problems or 100 derivatives. Work along with him. There's some excellent material there that the guy, and he's a phenomenal mind, by the way. But he'll always tell you to understand integration, you really need to be good at derivatives. And you need to understand and know identities. For example, an identity here. You can see this form 1 minus x squared. What do you think about? When I see that, I think about you have sine squared, we'll say x, plus cosine squared x equals 1. So 1 minus cosine squared x, what does that equal? Sine squared. Or 1 minus sine squared x equals what? Cosine squared x. So when I look at that, I'm thinking, oh, 1 minus sine squared. Now the reason I didn't choose to cosine is because the derivative of cosine is a negative sign. I'd have that negative sign I need to deal with. But in this case, I don't. And then once I change this, then I ultimately can take the square root of that and do something with it. So let's think about that. Let's take, we know the form, we have a squared equals 1, or a equals 1. So x then would equal a sine theta. So dx equals a cosine theta d theta. So now I have everything I need to work through this. So I can replace this with square root of a squared minus x squared. Well, if I square x, x squared would be a squared sine squared theta. So I'll just plug that in. X squared is a squared sine squared theta over x to the fourth. Well, x, we'll take this to the fourth power, so I'd have a to the fourth sine to the fourth theta. Now I have a dx I need to do something with. Well, that's a cosine theta d theta. Okay? Get rid of some of that. Okay, now then, let's factor this thing. I have the square root I'll factor out the a squared times 1 minus sine squared theta. Oh, you can already see what's happening here. A is 1, okay? So that becomes just a 1. That's a 1, okay? So I end up with all of this over sine to the 4th theta cosine theta d theta. Okay, square root of this is a 1 also, so that goes away. So I end up with square root of 1 minus sine square over sine to the 4th. Well, what did we say 1 minus sine square is? It's cosine square. So I have the integral, the square root of cosine squared theta over sine to the 4th theta cosine theta d theta. Well, the square root of cosine squared is cosine. That cosine times this cosine does give me a cosine square over, I'm going to break this sine to the 4th into sine square times sine square theta d theta. Now then, what is cosine over sine? Cotangent. So I have cotangent squared here times 1 over sine squared. What is 1 over sine, or what is 1 over sine? It's cosecant. So I have cosecant squared. So now I have the integral. Matter of fact, let me move that up here. I have the integral of cotangent squared theta times cosecant squared theta d theta. Well, again, knowing the identities is crucial. We've worked many problems with tangent and secant. They're friends, right? Sine and cosine, they're friends. Cotangent and cosecant are friends also. You know, the derivative of tangent is secant squared. The derivative of cotangent is cosecant squared. Well, it's actually minus cosecant squared. So I could let u, where's a good place to write this here? U equals cotangent theta du equals minus cosecant squared theta d theta. So if I solve, I should have picked a better spot there. If I solve for d theta, I have du divided by negative cosecant CSC squared theta equals d theta. Now then, what do we have? We have u squared. U is cotangent. Still have this cosecant squared theta times d theta, but that's du over a minus, I'm going to put it here, cosecant squared theta. Those cancel, so I end up with minus the integral of u squared du. So that gives me minus 1/3 u cubed. So I increase this by 1. 2 plus 1 equals 3, and I divide by the 3, and I have that negative out here. So I end up with minus 1/3 cotangent cubed theta. Well, we started in the x world, so we need to get back to that point. Well, how do we do that? Okay, we may need to clear us a spot here. I think we'll clear out this right here. And this. Okay, so we have minus 1/3 cotangent theta. As a matter of fact, we'll just clean out a side here, get us a lot more room to work. Okay, we had, oh, I should have left it up there, sorry. We had x equals a sine theta, right, earlier? All right, and we had, so x over a equals sine theta. Sorry, I got a little anxious with my erasing. Okay, so what does that mean for us? If this is theta, it said sine is the opposite over hypotenuse, x over a. So that would make this thing a squared minus x squared, and the square root of that would be the horizontal axis. Okay? All right, now then, cotangent. What do we know about tangent, sine over cosine? Cotangent then would be, so I have minus 1/3 cotangent. So it's cosine cubed theta over sine cubed theta. All right, so cosine. Oh, and by the way, that's 1. 1 squared is 1. 1 minus x squared, a equals 1. All right, cosine is going to be the adjacent over hypotenuse. So I won't write the 1 down. So I have minus 1/3 cosine, which is the square root of 1 minus x squared, square root of 1 minus x squared over 1, divided by, and that's cubed, by the way. That's cosine cubed. And then sine cubed, sine is opposite over hypotenuse, so it's x over 1 cubed. Now you can rewrite that and say, well, that's minus 1/3 1 minus x squared to the 1/2 cubed over x cubed. And we can also simplify that just a little bit more. Minus 1/3 1 minus x squared parentheses to the 3/2 divided by x cubed. And you may think, well, how did you get from here to here? Remember the rule, a to the m raised to the n power is a to the m times n. In my case here, I had a to the 1/2 raised to the 3rd power. So 3 times 1/2 gives me a to the 3/2. So that's how I ended up with that term here. Okay, fairly simple problem. If you knew various identities, if you could look at that and understand, whoa, that's, I'm going to let that be, looks like 1 minus sine square. So this becomes an a squared minus x squared format. A then would be the square root of that number, and then let x equal a sine theta and go from there. The other piece we needed to understand was cotangent, its derivative is minus cosecant squared. That's critical. If you don't know those few things, it's going to be a stumbling block for you. So study, study, study. Why are we doing this? Together we're trying to build a better tomorrow, and do that through math. Keep studying, guys. And that's all for now. Talk to you next time. Thanks.